Hi. In the last video, I started putting together the control logic midplane and got the control logic control module inserted into the midplane and tested. Now I have 16 of these control ROM modules that need to be added to that midplane, and each one tested individually. Now, getting into this, there's going to be a first iteration, last iteration concern for the loop to make sure that I actually get everything copied over. So I'm going to have to build some purpose-built tests to make sure that I actually get that working properly. There's a lot to do today. Let's get right into that.
Hi, I'm Adam. I'm still building a 16-bit computer from scratch. I'm no expert here. I make lots of mistakes. So many mistakes I've actually had to reboot my computer build. I hope you will find my journey interesting, and I hope you will join me as I learn along the way.
My wife Carrie has been working on a cookbook. Carrie's cookbook provides a unique culinary experience by seamlessly incorporating doTERRA essential oils into a diverse array of mouth-watering recipes, transforming ordinary meals into extraordinary dining adventures. The cookbook offers a treasure trove of innovative dishes that combine the health benefits and aromatic richness of essential oils with fresh, wholesome ingredients, making gourmet cooking accessible and exciting for everyone from novice home cooks to seasoned chefs. Each thoughtfully crafted recipe not only tantalizes the taste buds, but also promotes an overall well-being, harnessing the natural potency of pure essential oils such as lavender, lemon, peppermint, and basil. In Carrie's cookbook, she emphasizes the quality, flavor, and simplicity, guiding you through detailed, easy-to-follow instructions with beautiful photography and expert tips. Whether you're looking to elevate your everyday meals, explore new flavor horizons, or embrace a healthier lifestyle, Carrie's cookbook is your ultimate guide to enriching your kitchen and your life with the magic of doTERRA essential oils. If you are interested, there's a link in the description. The first control ROM I'm going to tackle today is control ROM 0. Control ROM 0 holds the asserts out onto address bus 1, one of which is obviously the program counter. So this is going to be important for making sure that I can actually execute code. Now the asserts out onto address bus 1 are decoded with a demultiplexer here. This is a 74HC238. The 238 differs from the 138 in that the signals are active high, not active low. This 0 ohm resistor is going to make it almost impossible to get to these pins, so I want to do the IC before I do that. And then after that, I want to go ahead and get the pins installed and get this soldered in so that I actually have control ROM 0 fully installed on the board. Soldering iron's warming up. Like I said before, I want to start with the IC. And then the capacitor. And then the 0 ohm resistor. Okay, let me see if I can get that cleaned up. Okay, and now for the fussy bit, and this is where I had struggled prior. I'm just going to double check my pins. I checked them before I started recording, but I want to make sure I've got them right. And I actually want to put that in upside down. Adam, what's so fussy about it? Well, getting everything lined up properly so that it all fits together is the challenge. Now this hopefully will be easier because I've only got 3 sets of pins. Yeah, I did. I got them situated. So now I've got to solder a pin on each one and then figure out how to flip this whole thing over so I can get the back side. That takes care of the top side. Okay, that should be it for control ROM 0. Now I've got to come up with a way to test everything to make sure that all my connections are working properly. This is control ROM 0 in the binary format. And if you look at this, you can see that it's going to be very difficult to test any particular bit pattern. All of the other control ROMs are very similar. So what I figured out I needed to do was to write a purpose-built test to populate a separate EEPROM so that I could use it for testing. And this is that program. What I'm doing is I'm going through and iterating through an entire 32K buffer and populating it with just the lowest 8 bits of whatever that address is. That's going to give me a value from 0 to FF or 255. Now, as I mentioned before, there is a first iteration, last iteration problem that occurs, at least for me in programming, where the first iteration of a loop or the last iteration of a loop doesn't always work exactly the way that you're expecting it to. And if you write any code, you're probably thinking, well, Adam, it's just a simple for loop. Why is that going to be an issue? Just use a for loop and then you don't have to worry about it. Some of the things that I deal with, programming languages, one of them is called RPG, or report program generator, and that does not have a construct for a for loop. Now you can build a for loop with some very basic constructs with that, but you still end up with a first iteration, last iteration concern that always has to be checked. It's just been beat into me over the years, and so what I've done here is the very first byte I have set to hex value AA, and the very last byte I have set to hex value 55. That gives me two very distinct patterns that I can look for that are out of place for the first byte and the last byte, so that I can make sure that I'm actually getting everything read into that RAM properly. Should be a very easy test. So I wrote that out to disk. And you can see the first byte up there is AA under the cursor. And then you can see on the right-hand side just a repeating pattern, including the ASCII characters. It's going to make that relatively easy to test. And now to confirm at the end, the last byte is 55 as well. So that should work out really well for me to be able to test. I just have to put that onto an EEPROM, and then I can replace C0 in my PCB with this test ROM and actually execute some tests. I'll get that done and I'll meet you back at the PCB. Here's my test EEPROM, and so what I want to do is replace this one with this one so that when I power it up, the contents gets copied into SRAM. Now down here, I don't need any of this anymore. This is just going to serve to make things complicated and confusing. And I'll take all of these out here in a second. But what I end up with now is this was the most significant bit, this was the least significant bit. I'm going to set these up in such a way that I can swap them manually, high and low, and select different patterns which can be latched. And that'll allow me to test whether or not the SRAM has been loaded properly or not. These are all set to be low, so the value for my address is 0000. Okay, what more do I need to do in order to fire this up and test? Nothing from what I can tell. Let's see what we get. Nothing is horrible. If I latch, I'm now over current. What I don't know is when this is done copying. There we go. So now if I've got 0000 and I latch that, that should be AA, and it is not. So now I have something to research. 0001, nothing. So the question then becomes, where's my problem? Okay, I'm going to work with the multimeter for now. I don't have quick access to my logic probe, or simple access to my logic probe. All right, so my address should be all zeros. And then over here should be my outputs. Let's see here. Let's bring up the pin diagram for the EEPROM. Okay, so pin 1 is chip select, and that's active low. So that's high. And that should be low for now. When it's done, it should go high. Perfect. Pin 2 is serial out, and that should be bouncing around about midway, which is good. And when it's done copying, it should go low, which is good. Pin 3 is write protect, which should be low all the time, and that is. Pin 5 is supposed to be serial in, which should start with some odd values, but then start shifting in zeros. And I'll take that as accurate. Yeah. The update is not quite fast enough to capture that, but that's okay. Okay, the next one over is the serial clock, or the shift clock, and that looks accurate. It looks like it's at least getting something in there. That kind of makes me wonder here. Okay, that's dead zero. The next one over is the hold pin, which is high and should remain high. And that looks like it does. So that's working properly. Maybe this is genuinely a first byte problem. Let's check the last. So let's see here. What is coming across as the address? That is not high. Okay, that's low. And that appears to be floating. That would be this pin right here. Yep, I've got a pin I've got to trace through and make sure is good. Let me look at that. On the screen, this pin right below the soldering iron does not appear to be attached. But there's a bit of a bigger problem here. I don't know if you can tell from this angle. But you see how these pins are bent? I did not actually get this lined up right. So the pins on the PCB do not line up with the pins on the midplane. And they look like they're off by 1/10 of an inch, which is not good. For me to be able to get my soldering iron in there, I have switched to my smallest conical tip, and I still am not, the soldering iron's not on. I'm not going to be able to fit it in there without actually melting away the plastic or nylon on these pins. And if I bend them out of the way, I'm going to be struggling to get them back into place in order to get them back into the backplane. I've got a bit of a mess here. So I am going to go for the bend out of the way method, just to try to get a little bit more room to get a soldering iron tip down in there. I am close and I should be able to make that work. I hope. Let's see how this goes. Alright, soldering iron is warming up. I need some flux for sure, because I need this to move very easily and flow very easily. And I need some solder so that I can get down into that space. That one looks good. That looks good, except for maybe that pin could use a reflow. I'll stick a little bit of flux on there. That'll be easy to take care of. And then it makes me wonder if these top three here are soldered down. So I'm going to put a little bit of flux on that, and I'll touch those up as well. Is that soldered? I believe that one is. I should be able to push on the pin. That's soldered in. That is soldered in. This one, it's this one I need. Yeah, I'm not thinking that's soldered in. Alright, so let's start with these here first. All but the last one. Okay, that's good. This one I was going to touch up. That looks good. And then these, which are very tight to get into. Okay, I don't think I melted anything. Let me clean this up and we'll give it a try again. Okay, so the biggest deal now is to get all of these pins lined up into this socket here so that it can all sit down properly. And I am not certain I'm going to be able to do that very easily. So let's get that out of the way. I'm off by 1/2 of an inch. Okay, so these all need to kind of bend over. That looks reasonable. That looks reasonable. Looks like I've got everything lined up. Let's hope I don't have to take that back out again. Alright, VCC is up here on top. Ground is on the bottom. And then each of these need to be placed. Lily, you're pathetic. What do you want, baby girl? Can't you see I'm recording? Are you hungry? Or do you need to go potty maybe? Or are you just looking for attention? Oh, you want to go potty, huh? Alright, let's go potty. Okay, let's give this a test and see what happens. Not sure this is the only problem. It certainly was one of the problems. And I did manage to dig out my logic probe, so I'll use that to do more troubleshooting. It's got a finer point on it than the logic probes do. I'm sorry, than the DMM probes do. So it makes it a little bit easier to get into some of this fine pitch work up here. So it's running through and it's counting now. Once it's done, I am expecting this to be all high. All of those signals to be high. So this should be the most significant bit. And if I latch, okay, so high, high. And I've already gotten past the one bit that was giving me trouble, so that's good. And that should be low. And that's correct. See, all of those are outputs, and none of those are actually producing a signal. So I have a problem with my chip select or my output enable. My write enable is low, which that should not be. So where is my write enable pin coming from? These are all my control signals up here in the corner. I got out the old breadboard. I've got it hooked up into the clock here. The PCB is still hooked up, but when I hit the reset button here, you can see I'm counting on the breadboard. When it's completed, what's important is the write enable on the SRAM is high, it's not low. But whereas over here, write enable is low. So down here, write enable is high. Up here, write enable is low. That's not the way it's supposed to be, and I've got a translation error between the breadboard and the PCB. So this PCB is going to need to be respun. But what is the translation error? The signal that drives this write enable signal going high on the breadboard is connected to NAND gate 2, pin 3. If I look at the schematic, NAND 2, pin 3 is QL. But if I look at what signal goes to the SRAM write enable, I've got the inverted QL. So I quite simply picked up the wrong signal there. So before I go any farther, let's clean this up and make this right, so that that actually now has the correct signal. That's going to change the PCB. I'm not going to respin that just yet. I want to see if I can actually bodge this. So where is this on the PCB? All right, looking at this connector, pin 12 is that signal that travels off board. It needs to be QL, not inverted QL. So it's relatively easy. On the back side, I can cut that trace. And then I can pick up QL from either pin 3 or pin 4, and it really won't matter if I bridge those on the 74HC00, and then tack that down and route that up here to pin 12. Let me clean up a little bit, make some room on my desk, because I have not done this before, and it's going to take me a little bit of effort to try to figure this all out. I'm under the microscope again so I can somewhat see what I'm doing. And I'm getting my knife ready here. So it's this trace right here that needs to be cut. And again, I've not done this before, so I am not exactly certain what I'm going to expect. Well, unfortunately, my audio went south at this point. I'm going to do my best to try to voice over what's going on and hopefully keep up with the video. It took a couple of attempts for me to cut the trace. I was finally able to confirm that by double checking pin 6 of the IC against pin 12 of the pin header. I'm using some 30 gauge solid core wire wrap wire as my bodge wire. It's yellow so that it stands out pretty good. I strip about 1 millimeter off the end of that, and I'm able to very quickly and easily attach that to pin 3 of the IC, which is really the signal that I'm looking for. The big blob of flux and some solder on the tip of my iron make quick work of that. I'm so confident in my work, I go straight to cleaning it up with a cotton bud and some IPA. Now here's where the trouble starts. I try to route that bodge wire to the pin header pin 12 and get it cut and stripped to size before I start trying to solder it. That turns out to be far more difficult than I had thought it would be, and I end up actually ripping the wire off the pin 3 of the IC several times. Ultimately, I end up cutting a wire that's longer than I need and kind of routing that into place. It's not pretty, but it should get the job done. I'm inserted back into the mid-plane. Now, do I think this is going to solve all of my problems? No, I do not. I'm certain I've still got something else going on up here. I'm not exactly sure what it is yet, but let's see if we can figure that out. Now again, once this is done copying, I'm expecting 5.5 to show up here. No, I take it back. I'm set here to address 0, so I'm expecting AA to show up here on the LEDs. Okay, it's done copying and I've got high, so let me tap one additional clock cycle. Yeah, that's the least significant bit down here. That's the most significant bit up on this end. So this is 40 for address 00. And that's not correct, obviously. So let's look at address 1. No change. That's address, that's 40. If I look at address 2, I now end up with 30. Address 3. I'm back to 40. Address 4, that looks like 14. Address 5, that looks like 0C. So this is not quite working the way that I need it to. Got those messed up. Let me get those back in order. I'm going to go all the way up to E7F for the address, which is the last byte. The last byte is supposed to be 5.5. And that's 0. So, long story short, something's going on here that I need to try to get to the bottom of. let's take a look at first the addresses coming in. This should be 7F. So the address is correct. Now the address on the SRAM is correct. So my outputs, the outputs match what's on the LED display, which means that I've got a translation problem getting from the EEPROM to the SRAM. That's likely going to be here in this shift register. Okay, so the most important piece here is trying to understand exactly where to start digging into all this troubleshooting. What I've got is I've got my oscilloscope set up here. It still doesn't report voltages right, but I can still see signals properly. These sockets up here on control ROM 4. So this first pin is the EEPROM chip select. My trigger is set up on rising edge for that channel. When I reset, it starts copying and I get a bit of a bounce here. So I'm going to have to try to dig through that and find out what's going on. But the last chip select should be the one that persists. And then you can see I've got the rising edge, which brings it back high. The next one over is the command shifted into the EEPROM plus the address, which is shifted into the EEPROM. And when I reset that, I end up with one high bit, which is shifted in, and that's the end of that. Nothing else is actually shifted in, or more specifically, everything else that is shifted in is a 0 or low bit. The third one along is the latch output enable. Now that's for the line driver, which is driving the results off the latch. And you can see it goes high as it's resetting, remains high, and I'm expecting once it's done, well, I was expecting it to go low. Oh, it's a rising edge. So I don't actually get to see that go back low unless I change that to be a falling edge. There it is. The next one along is the shifter output enable. So that's the line driver for the shift register. That is the output of the shift register that is going to be loaded into the SRAM. Again, I'll do a reset on that. It goes low. It is actually doing that. I'll switch that over to rising edge. Once it's done copying, I get the rising edge. The fifth pin along is the shifter reset. And that looks like a whole lot of noise. That certainly does not look right. It certainly does not look concrete. I've got to trace that back a little bit and see if I can't figure out where that mess is coming from. Let's put a bookmark in that for a minute. The next pin is VCC. The one after that is ground. The next one over, which is pin 8, is the copy clock. So when I am copying, it will be issuing those clocks and then stops once the copying is complete. That seems like a reasonably good signal. Next two are ground, and then after that is the CPU clock. So when I am resetting, it is issuing clocks, but when I stop, it only issues clocks as I press the button. Next one along is ground and VCC, and then I've got the SRAM output enable. Write enable. So as I'm resetting, I'm getting a write signal with each byte that is supposed to be loaded, and then again it stops. Then SRAM output enable, to make that the falling edge, and I don't expect to see anything there until it's done copying and I get a falling edge signal. And finally chip enable, and I expect this to bounce a little bit like the write enable did, and that's good. Once again, I expect it to stop, and it did. So really what the concern that I need to dig into is that shift reset pin. Because for some reason that looks like it's floating. Now see, now that stops once it's completed its copy. But it looks like it stopped at something that is not 5 volts or 0 volts, so let's confirm that. Let's drop that right there. Let's put this on pin 5, and then I believe that's ground. Comes up to 4 volts, and then when it's copying, it's kind of bouncing around a little bit, but it's up as high as close to 5. It is bouncing, and then it comes down to 4 volts. Well, there's nothing in my system that should be issuing 4 volts. So yeah, we've got a little bit of digging to do. And what I need to do is I need to now find this signal over here on the control ROM control and see what that's showing up as. Shift reset is not QR, but it's specifically on pin 3. No, that should be on this one. Yeah, that's 4 volts. So while it's copying, it is showing close to 5. Once it stops copying, it drops down to 4 volts. So I need to trace this back. This is going to be another issue here on the control ROM control board. And that's coming off of QR inverted. QR inverted is pin 5 on the 74HC74. And not QR. So QR and not QR. Double check here, not QR is pin 6. So that should be this one. That's still issuing 4 volts. So here's where that trace goes. It is used in several signals on this PCB, but it also travels off board. And every one of these has a potential of having some kind of a short or something that's causing issues. But I can say for certain that's issuing a 4 volts. 4.89 and then down to 4. Yeah, there's something wrong there with that one of those traces, or that IC. So I need to likely just replace that. I don't know what to do next. Let me think on this. Alright, so what did I decide? Well, what I decided was I was going to go ahead and take this IC off. This is the one that appears to be malfunctioning. I don't know for sure that it is. There could be something else on the board that is creating a problem with it. But if I don't get it off the board, I'm not going to be able to discern or figure out if there's something else, or at least it's beyond my skills at this point. So I'm going to use hot air to desolder this, but I've got a lot that I need to protect around it. So I've got some foil tape here, and what I'm literally going to do is cut this into strips and see if I can't protect some of these other components here, so that when I apply hot air, I end up with a little bit more controlled action there. I need a better pair of glasses. Alright, now if I remember correctly, this stuff is not the easiest in the world to work with. It's not the easiest in the world to peel for sure. I actually can probably get multiple out of this. Okay, hopefully that will protect that spot. Okay, and then one more little sliver. See if I can't protect that capacitor real quick. Alright, if I understand this correctly, that should protect all of those other components. And I am to understand that it does do that a little bit better than Kapton tape does. So let's find out what's going on with that. Now I have replaced the nozzle on my heat gun with a larger one. And I'm going to turn the airflow up all the way. And let's see how quickly this melts. Of course, it helps if I keep it on the right side of the foil. That was actually relatively easy. It looks like it might have left some adhesive behind that I've got to clean up. And then the last thing is to wick off all of this solder that's left behind, and I'll use some flux for that. And while I'm at it, I'll touch up this capacitor again because it looks like it took a little bit of a Took a little bit of heat on the solder joint there. Okay, let me get a new IC and we'll see if that improves my situation here. So this is where I'm going to replace that 74HC74. Pin 1 is up here. And the downside to using the foil was all of the adhesive that got left behind. So I am hoping I didn't make this situation worse, and I'm able to actually get good connectivity between the IC and the PCB. Here is the IC. And it's kind of tough to see. There is a line right there which indicates where pin 1 would be. So as before, the goal is to get this settled in place. Well, let's get some flux on there first. Let's start with that. And I'm going to try to tack down a pin here. Okay, and then some solder. Oh, let's pick that pin. Okay, let's spin that around. A little bit of IPA to clean up the flux. I'm going to be careful I don't pull that bodge wire out. Alright, let's put it back in the board. We'll give this a shot and see if this actually improves my test results or not. That'll determine if that IC I pulled off is still good or if it belongs in the bin. PCB is reinserted. Turn on the DMM. The key here is going to be a voltage check on those pins. I'm going to pick up ground up here, and then I will power on, and then I need to check pin 5 or 6. Okay, that just dropped down, and that's still 4 volts. So something else is dragging that voltage down. Let me double check that signal, and it's back down to 4 volts, 3.8. Something's pulling that down. So it's not this little dude, it's something else on either here or here. Okay, how can I measure this to determine exactly what that is? Let's try it again without this in place. Okay, and the reason I want to do it without that in place is it could be what's pulling things down. No, I'm getting 4 volts here. So that's either going to be the mid plane or it's going to be this that's pulling it down. I spend the next few minutes looking at different things. Ultimately, what it boils down to is I've got to figure out how to isolate the problem. Let's do that. I pulled the control ROM control off the mid plane. This will help me determine if the problem resides in the control ROM control or actually in the mid plane. And then I soldered on some leads so that I could connect this up to my clock module. And in particular, I'm taking the raw system clock off of it. The actual clock itself is only used for the control ROMs. It's not used for the control ROM control. And then I've got a reset line and then power and ground so that I can power this. Okay, let me power this up and let it go through its thing. And let's measure the result here on pin 5. 0 on pin 5. Pin 6 is still down to 4 volts. I want to bring in the oscilloscope. With the oscilloscope set up, if I touch pin 6 here, you can see I am getting some sort of a clock signal. Now, where in the heck that is coming from, I do not know. Now, I know I do have clock here on pin 3, and how it's bleeding over into pin 6 here, I'm not sure. I do have a decoupling capacitor here for the IC. I have been able to determine that the ground connects to the ground side and that the power connects to the power side. Trying to get on top of this capacitor here. Okay, so at this point, what that tells me is that I have a problem either on the control ROM control PCB, or I have a problem on the IC here. It's less likely that it's the IC, because I've had two that are exactly the same behavior, so more than likely it's coming off the board here. What that might be, I am not certain at all. Okay, that said, I do have a 74HC74 IC that I have desoldered, and I can turn around and I can add leads to that, which would then allow me to drop it into a breadboard and actually test it independently of the PCB here. I honestly am not certain that's going to be the problem. I'm going to blame the PCB first, but I don't know how to narrow that down other than removing ICs one at a time and trying to make sure that I can get that working somehow and remove that odd signal, adding them back in one at a time until I actually have things working properly. I'm not exactly sure what the best approach is to try to figure that out. If anyone has any recommendations for me, please leave it down in the comments, because I am well outside of my abilities and well outside of my comfort zone at this point. So at this point, I'm going to leave this video here. There is so much more to do that there's no way I can fit it into a reasonable length. So unfortunately, there's going to be a follow-up to this one, and I will start working on that immediately. I am going to look for your recommendations, so thank you in advance for any help that you can provide. We'll see you soon.